So our goal here today is being able to factor quadratic trinomials. So I can factor quadratic trinomials if possible. So we're going to be using the diamond set patterns to help us out. So this is kind of what we're using to help us figure out whether or not we can factor. So looking at our format, we need something of the form ax squared plus bx plus c in order to apply these factoring patterns. And essentially, this is standard form. So you have an x squared term, an x term, and a regular number. Okay? You have to have that in order to use these patterns that we're going to discuss. All right. So the idea is if you can do this diamond thing, if you can do this patterning, then it's factorable. Not everything is factorable, as we've already discussed. Some things like 7 or 13 as numbers are prime. They only divide by 1, and the same is true of polynomial sets. So we are going to go through a process of how do you decide if it factors or not, and how you find those factors. So this is our example here. So our example problem, 15x squared minus 4x minus 4. First of all, when we're looking at a format ax squared minus bx or plus bx minus c, note that the coefficients, which are a, b, c, are the numbers, not the variables. So the coefficient on x squared, the number in front of x squared is 15. The number in front of the number at the end is negative 4. The number in the middle in front of x is negative 4 as well. So our first step is to take the first and the last coefficient and multiply them. So 15 times negative 4, negative 60. When we're doing our diamond set, that number then goes on the top. So I'm multiplying for AC. Okay? And what I want to find is essentially factors of that number. So I'm looking for factors of the number 60. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 4 and 6. Notice these are all regular whole number factors, and I'm not worrying about, actually not 6. So 4 and, actually wait, I don't know what I was even doing with 4 and 6. Sorry. That should be 6 and 10. So I'm not worrying about signs right now. I'm just worrying about numbers that multiply to 60. Okay? Then for the number in the middle, which is b, so b being negative 4, okay, that's the number that goes in the bottom. So negative 4 in the bottom. And essentially, I want to be able to add to this number, negative 4, and multiply to this number, 60. So it's an adding or subtracting problem. So now I kind of go through and think about what numbers add or subtract to 4. Well, if I look at this bottom set, 10 plus 6 is already 16, and that's the smallest set I have. So there's no way I'm going to be able to add to 4. That's not possible. That means it's a subtraction problem. So let's look at this. 60 minus 1, no. 30 minus 2, that's 28, no. 20 minus 3, that's 17, no. 15 minus 4, that's 11, no. 12 minus 5, that's 7, no. 10 minus 6. Ah, there's a 4. Okay? Not quite yet, because what I'm supposed to have is negative 4. So, that means I probably need to change my sign. So let's do negative 10 plus 6, and now that does equal negative 4. So we're going to put those numbers in, negative 10 and positive 6. I already checked this. Negative 10 plus 6 is negative 4, so that's check on the bottom. That worked. Negative 10 times 6 is negative 60. You need to make sure your signs match. Okay, so positive, positive, negative, negative, and so on. All right, so this is step 1, finding the pair that multiplies to the A times C and adds or subtracts to negative 4. Okay, these numbers here are what we're going to use. All right, so all this was for is to find the numbers that will make it factor. All right, so we start again with our set. So here's my original set, 15x squared minus 4x minus 4. Okay, there are 3 terms right now. In order to factor by grouping or any other factoring, this particular strategy, in order to use it, you need 4 terms. So how do we turn it from 3 terms into 4 terms? Well, we're going to take this middle number, which was negative 4, and we're going to make it into the 2 numbers we just found, which is going to be plus 6x and minus 10x. So notice that these 2 numbers here come from here. So basically they come from your diamond and then they go in. All right. That's what you're using the diamond for, is to find those 2 numbers. All right. Now what we have is 4 terms. So now we can move forward with our factoring strategy. So factoring by grouping. So we're going to start with the grouping method. So let me write what it says. 15x squared plus 6x minus 10x minus 4. So grouping, first 2 terms. Remember, I need the sign in the middle to be a plus, so that negative needs to be on the 10. Group the second 2 terms. Now what am I doing? Figuring out what my common factor is for each pair. So x is common here on the first set, and then 15 and 6 also both divide by 3. So I divide out a 3x, and then what I've got after I've divided is going to be 5x plus 2. So 15x squared divided by 3x, 6x divided by 3x. Next set, remember you have to match the first sign. So this is negative 10, so I'm going to have to do a negative greatest common factor. I don't have x's common, but 10 and 4 both divide by 2. So put a minus 2 in there. That's what I'm dividing by. Once I've divided, negative 10 divided by negative 2 is 5, so 5x. Negative 4 divided by negative 2, so plus 2. And then remember on grouping that your next set right here, these have to match. So if they don't match, here's the thing. If this worked, the diamond set worked, that means this works, and that means this works, okay? So if you have your first thing, that means everything else, that works, that works. So if you have something that's not working, that means you made a mistake somewhere, and need to go back and correct it. But anyway, I managed to make them the same. So that is now what I'm pulling out, 5x plus 2. And then what I did not highlight, what I did not pull out is 3x minus 2. And that is my factor pair. So now I have changed it from a expanded set with no factors to a factored pair with parentheses. So I'm saying if I break it down, 5x plus 2 multiplied by 3x minus 2 will give me back 15x squared minus 4x minus 4. If you choose grouping, you're pretty much using a division strategy. So you're dividing out a GCF and then finding what's left over. If you choose this strategy, the reverse box, it works basically the same way. It's a grouping strategy, but in the reverse box method, it ends up that you're looking more for things that multiply versus things that divide. So it really is a choice of which makes the most sense to you. First step, put in your numbers. So I put my numbers in the box that I had, and where did those numbers come from? Right here, your 4 terms, they just feed into your box. So the next step is figure out what multiplied into here to get this box set. So I'm going to start with the first box. The first box is basically what I just yellow highlighted. So I multiply what's on the left and on the top to get the 15. My values, obviously it's x squared. So I should always split my first box, which should always be a square on this methodology, into x and x. So x squared is x times x, so that takes care of x. 15, most likely 3 and 5. So I'm going to try putting the 3 here and the 5 here. Maybe that's right, maybe that's not. What I'm seeing is then, okay, look, this 5x times some regular number needs to multiply to 6. And I know 5 times 1 is 5, and 5 times 2 is 10, so that's not going to work. But I know it factors because I have the diamond, so this has to work. So what does that mean? It's essentially probably the 5 and the 3 are the wrong pair, or they're in the wrong place. So what I want to kind of do is look at this number here, and I want to think about, okay, 3 and 5. Is there a 5 that multiplies to 10? Well, 5 times 2 is 10. Okay, how about 3? 6. Okay, so probably I just messed up my placement. So 5x, 3x, and then I'm looking at the next box. So what I'm going to fill out is what's in blue. Okay, so I don't need to worry about the x because there's already an x on 6x. So what I need is 3x times some quantity is going to give me 6x. I already have x, don't need another x. So 3 times what is 6? And that would be 2. Okay, let's try the bottom left box. To get that space filled, I need to think about 5x times something will give me 10 to fill in this thing. So 5 times some number gives me negative 10. Again, I don't need to worry about the x because there's already one there. So that value would be negative 2. Then my last thing is my last box correct? Is it correct or not? And how I check that is I take, okay, so this negative 2 and this 2 have to multiply into the last box. So what is 2 times negative 2? It is actually negative 4. So that is correct. So what are my factors on this? It's what you wrote on the top multiplied by what you wrote on the side. And do not forget your parentheses. So my factors are 5x plus 2 and 3x minus 2. What I should notice here as well is that this factor pair, 5x plus 2 times 3x minus 2, is exactly the same as the other factor pair. And that is what has to happen because these are two different strategies that should give you the same set of factors. Okay. Let's look at some examples. So if I'm doing examples, okay, What is A times C? A is 9, C is 2, 18. Factors, 18 goes on the top, so 1 and 18, 2 and 9, 3 and 6. What is the middle term? That is 9. That's what goes on the bottom. And I'm looking for adding or subtracting to 9. Hopefully I can easily see that 3 plus 6 is 9. 3 times 6 is 18. Those are the values I need. So looking at my original set, 9h squared plus 9h plus 2. What am I doing? I'm splitting up the 9. So 9h squared plus 3h plus 6h plus 2. So these numbers here, I'm only finding them so that I can turn them into part of my equation. Then what do? I group my set. So group the first two, group the second two. H is common, 3 is common, 3h is what I divide out. Left is 3h, and a number over itself, 3h divided by 3h is 1. Okay, second number, 2 is common. 6h divided by 2 is 3h. 2 divided by 2 is 1. So then 3h plus 1, because those are the same. And then the second factor is 3h plus 2. And then that is my factor pair. All right, so let's see. 3, 15 for B, 45, 45, 1 and 45, 3 and 15, 4 does not divide, 5 and 9. Okay, on the bottom, on the B, I'm looking for 19. So I'm looking for two numbers that add to 19 and multiply to 45. So I've got my factors. If I think about adding, 1 plus 45, 45 minus 1, that is not going to work. 15 plus 3 is 18. 15 minus 3 is 12, so that doesn't work. 9 plus 5 is 14. 9 minus 5 is 4, so that doesn't work. So what happened is, oh my gosh, I have nothing, okay? So what that means is this is not working, so this is a no. And essentially, if that happens and you cannot find a pair that functions for your problem, what that means about your original problem is it is prime. So it does not factor using these techniques because it has no whole number, whole polynomial with regular coefficients. So it might do something, but we're not going to be able to do it with regular numbers. All right, let's try the last one. 2 and 12, first coefficient, last coefficient, 24. So 24 is the number I want to multiply to. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. The number I want to add or subtract to, negative 11. Okay, so 24 plus 1 minus 1 is not going to add up to 11. 12 plus 2 is 14. 12 minus 2 is 10. No. 3 plus 8, 11. Maybe. 4 plus 6, 10. 6 minus 4, 2. No. Okay? Most of the time there's only one choice. Sometimes there's more than one choice. So you need to check all your pairs. But let's see. I've got 3 plus 8 equals 11. Unfortunately, that checks to the 24, but not to the negative 11. So what I really need is negative 3 minus 8. So I have negative 11. So if I make these both negative, then this checks. And then negative times negative is positive, so that checks. So let's write our four-term set. 2z squared, negative 11z turns into minus 3z minus 8z, and then plus 12. So now I've got my four terms. And looking at the other method for doing this, I'm going to draw my box. Again, I have 4 spaces, so I need 4 terms to fill them out. 2z squared minus 3z minus 8z plus 12. All right, so let's look at the first set, 2z squared. What multiplies to 2z squared? Well, 2 is 1 and 2. Z squared is z and z. So I know it has to be z and z. I'm thinking about it. If I write 2 times a regular number being 3, because 3 is over here, 2 times 1 is 2, 2 times 2 is 4, so it's not going to work. So probably the 2 on the top and the 1 in the front. So let's try that. So 2 on the top, 1 in the front. So 1 times negative 3 is negative 3. That works. 2 times something is negative 8. So that is going to be negative 4. Okay. And then what's my last thing? Is that negative 4 on the bottom and negative 3 on the right need to multiply to positive 12. So basically, what I'm saying is this number and that number need to multiply to that bottom box. That's how you're multiplying, is across and down. So negative 4 times negative 3. And that is positive 12, so that works. So I now have my factors. The top number is 2z minus 3, and the side factor is z minus 4. And that is how I basically figure out my factors. There are some shortcuts, which we'll talk about later, but that's the main process for factoring. Bye-bye.